Alright guys, so today it's a cold winter day here in Green Hill, and we're going to be talking a little bit about this black walnut tree. Black walnut is a traditionally high valued species of tree, and the reason they're high value is because the wood has this really nice grain structure, has a really dark color, and traditionally it's been used for things like furniture and gun stocks and things like that. But black walnut has some other really interesting features, and I want to show you those because it will help you understand a little bit about the life history of the tree, but also give us an opportunity to look at some basic physiological features that black walnut has, and to get a better understanding of how chemicals move, how water moves through the tree, and just by looking at some of those external structures that black walnut twigs have. So join me as we take this look at black walnut. Okay, so as we're looking at this twig, some things I want to show you as far as its anatomy is concerned. First of all, let's look at these little gray spots that you see here on the twig. I hope you can see them in the camera. These are called lenticels, and lenticels are basically breathing tubes through which gases such as carbon dioxide and oxygen can move through the plant, particularly at night when the plant is going through respiration. This also occurs during the day as well, but more respiration occurs at night than during the day. This time of year, there's not as much taking place with this tree because it's dormant. Okay, so it's not doing anything as far as right now. It's just kind of just working its way, trying to get through the winter. But during the growing season, the stem is able to help the plant to carry out respiration. Because remember, respiration is a process for all living things, and so it's part of the metabolic aspect of this tree. Photosynthesis occurs in the leaves because that's where the chlorophyll is, and so that's what's able to occur there. Now, if we look carefully here, we see that this twig also has these little scars, these little triangular shaped scars, and these are called leaf scars, and this is where the compound leaves of this tree were attached. Okay, and if you look inside of those scars, and again, I don't know how well you can see this, but you'll see these little dots inside, and these are part of the vasculature, or the vascular tissue that allows for transport of sugars and water and those kinds of things through the leaf. Okay, because if we were to look, these little bundle scars here, they tie into the vascular tissue of the leaf, and so it's moving sugars and such from the leaf down to the root using this tissue system, and it's moving water and minerals from the root up through the stem into the leaves through the same system of tissue. So you'd have xylem and phloem found in this area. Now, if we go further up on the stem, right above this leaf scar here, we have a bud. This is called an axillary bud because it's found in the axil of the leaf, and the axil would be this little, where this leaf, it would have kind of this little V shape. Okay, the axil of the petiole is where this bud grows from. So this is an axial bud, or a lateral bud is another name for it, because it's found on the side of the stem. Okay, and so you notice there's several axial buds here, or axillary buds, or lateral buds. There's several on this stem, but at the end you've got what's called a terminal bud, and a terminal bud is where the next season's growth will occur from. Okay, this bud is very important, okay, because this is from this bud the new growth will occur. So this is a node here, and from this node you'll have an internode, and then there will be a new terminal bud out on the end of the stem. Here's another one. This is a terminal bud here. Okay, so one of the things that is important to note here, and we'll be talking about this in class, but if you took and you pinched this off, say you removed this terminal bud here, okay, this will trigger these other buds to produce woody tissue and branch outward, okay? So as long as this terminal bud is in place, okay, it will continue to grow longer. It will continue to lengthen, okay? This is what we call crown dominance, okay, or canopy dominance, okay? But as long as this terminal bud here is in place, then that will continue to lengthen. But if you took that off, okay, then what will happen is one of these axillary buds will actually become the dominant bud, and it will branch out. And so you'll get lateral growth from the stem at that location. Now, in some cases, this is good. In certain plants, it's a good thing when that happens, because what it does is it keeps the growth more compact. It keeps that tree from getting larger or from growing long branches and things like that. So when you remove those terminal buds, that's what happens. This will stop growing higher or taller. Instead, it'll grow laterally. So it'll grow outward. But we want to make sure that we manage the growth here by just kind of leaving this alone. So we're not going to really do anything to this, okay? But one of the things I'm going to show you in just a second is I'm going to take a cutting off of this. I'm going to actually cut it back to the stem, and I'm going to show you what the inside of black walnut looks like. But it's a really interesting species that we're looking at here. So we've got lenticels, which are the spots. We've got leaf scars, okay? Inside those leaf scars are bundle scars. We've got our axillary or lateral buds, okay, which is where next year's leaves will come from, okay? And then on the tip, we've got a terminal bud, okay, which is where the next season's woody growth for this particular twig will grow from, okay? And then you'll have a new terminal bud at the end, okay? Between each of these leaf scars, okay, is an inner node. So this space here is the inner node where the leaves grow from. These are nodes, okay? And if we look, pay close attention, we see that the leaf scars are alternate from each other, okay? So there's one scar per node, okay? So this is what we would call an alternate leaf pattern. If these were opposite, if there were two nodes or two scars per node, then we would call that an opposite leaf pattern. So this is alternate leaved, okay? The leaves on this are compound. We can't see them because they've already fallen off and pretty much rotted. But that's just a little bit of information about this black walnut tree. All right, so what we're going to do is we're going to prune this twig off of this little branch here, okay? And there's a certain way that I have to do this, okay? I've got my Corona pruners here, okay, which help me to make precise cuts on this twig so that I'm not creating any significant damage to the branch here, okay, because I want it to grow new twigs from this. But what will happen is when I cut this off, okay, the branch produces hormones, or the tree itself produces hormones. Those hormones will come up here to where this wound is, and it will tell it to seal itself off. So it will grow new cells, okay, that will basically seal that wound and prevent pathogens from getting in that could potentially damage the tree and create an entryway for disease, okay? But it will also stimulate new growth, okay, around that same area. So it will create new tissue that will allow for leaves to come out and to form a new twig to replace this one here. And it will probably come out somewhere between where these two joints were. Okay, so what I'm going to do, let me get my pruners here and open them up. So I don't want to cut too close, because this little junction right here, this is called a branch collar. Okay, where that's found, that's where those important cells are that will help to grow a new plant, or excuse me, a new twig. So I don't want to cut that, but I do want to cut just above it, and I want to kind of make my cut at a certain angle so that it's not going to be, you don't want to be too steep, okay, but you don't want it to be too shallow either. So I'm going to kind of cut it at an angle that kind of is a little bit offset from what you see with the branch collar. So we cut that off, and now if you look inside there, you can see this round part inside there. Okay, this is called the pith of the plant, P-I-T-H. Okay, and I'm going to use my twig to help show you this. But if you look around the outside, okay, you see this darkened ring of tissue that's found around the outside, close to where the bark is. Okay, this is where your xylem and phloem is. Okay, remember the xylem is what moves water up the stem to the leaves. Okay, and your phloem is what moves your sugars and everything down to the roots. So xylem and phloem is found in that really dark section there, and so that's where all of that material is. All this other tissue is just woody, corky tissue, okay, that is, you know, stored cellulose and things like that is what that's mainly composed of. What we're going to do, though, is here in a second, we're going to look at the actual pith of this twig that I'm holding in my hand. So we want to check that out.
All right, so now we're back at the Calhoun laboratory, back at my house, and we've cut off the branch from the black walnut tree, and we're actually looking at the pith of this tree. So you see this twig at the bottom of the twig, and I've carved away some of the wood so that we're actually looking at a cross section of the twig. Now you may hear some cars go by because we do live here on the road, but if we look into, as we're looking at this twig, you'll notice that that black line there that you see, that's the pith. And black walnut has something known as a chambered pith. And when we call it a chambered pith because what it's made of is these little chambers. And there's a tissue called sclerenchyma that makes up the pith tissue there. And it creates these little membranes that are found going all the way across the stem there, across the pith. And there's nothing inside of those little chambers. It's hollow, other than that sclerenchyma membrane that you see all the way up the stem. And if you were to shave that stem or that away on the stem, all the way the entire length of the twig, you would see that the whole every bit of the pith looks like that all the way through. So it would be very uniform in the way that it looks. So I just wanted to show that to you. Now, at the same time, just to give you something to compare that to, okay, I'm going to introduce this poplar twig in here as well. And so if you look at it, okay, poplar has a more homogeneous pith, and so it's composed of mostly parenchyma tissue, which gives it this spongy texture. And you will see that there's no chambers or anything inside that pith. Now, there's another type of pith called diaphragm pith. And in diaphragm pith, what you would see is you would see the little sclerenchyma membranes, and then it would have parenchyma embedded in between those membranes. So that would be something we call a diaphragmed pith. So we have technically chambered, diaphragmed, and homogeneous. And what we're looking at here is homogeneous. Now, just to do a little comparison here, and it also gives a good opportunity to look at a different type of stem. Let's look at this tulip poplar stem. I'm going to turn it around here so you can actually see it a little better. Okay, I'm gonna move my walnut stem here. Okay, so you should be able to see this much better. But you can see the terminal bud, which is here on the tulip poplar, and just below that you can see a leaf scar. Okay, and an axillary bud there. Okay, that's where a leaf will come out. Okay, but from this point right here, this terminal bud, this will grow another shoot. Okay, it will be this coming season's growth. Now, one of the things that you can see on poplar in particular is if you kind of roll it over, you can see it has this line that goes around, that encircles the stem here. This little line right here. Okay, this is called a bud scar. And essentially what happens with a bud scar is for every year that this grows, okay, so this is this past year's, or actually this is this past year's growth, but every time this shoots, okay, it leaves a scar behind, okay, called a bud scar. And this also has scars on it where the leaf attaches to the stem, okay, and we call that a stipule scar. And it looks very similar to the bud scar, but the stipule is this leafy structure that winds around the stem that's actually attached to the petiole of the leaf. Okay, and if we look careful here, we can see the buds. Okay, if you look, you can see the little holes in there, or excuse me, the leaf scars. See the leaf scar there, and in this case, compared to the walnut, which has kind of a V-shaped scar, this one has more of a round scar, and you can see the little tiny bundle scars inside there. At least hopefully you can see that on the video. Okay, but here we are looking at our axillary bud and then our terminal bud out here on the end. But it's nice to be able to do comparative analysis with different types of branches, and this is, or twigs rather, and this is how we're able to identify different species, is by looking at their twigs. So notice the difference between this walnut twig and the tulip poplar twig. You can see a lot of variation between both of these just by looking at the different leaf scars, the arrangement of the buds, and so forth. So it's a very good comparative analysis that we can make between these two species, and you can do this with any woody species. All you need is a key, and that's one of the things that we will actually be doing. We'll be actually looking at some woody plants and how to identify them using their twig characteristics. But I just wanted to show you that as part of this video. So hopefully this gives you a better understanding, particularly as it applies to pith, okay, which is that part in the middle there of the twig, and you can see all those little chambers in there. Okay, so hopefully this gives you a good idea of what we're talking about. All right.
Okay, the last thing we want to talk about is the black walnut tree itself. It's got this really interesting dark brown bark, which is one of the ways that we can tell that it's black walnut. Okay, we also can come over here on the ground and we can find the nuts that squirrels have left. Okay, there's still a few here. Look at this big pile of stuff over here that the squirrels have picked up. Now, black walnuts are really, really hard nuts, and you'd have to be a squirrel or some other similar rodent to be able to actually get through this shell, because the shell of these things is really hard. I mean, the only way you can break these things open is with a hammer, because they're so hard. But you can see a squirrel's chewed on this one. Okay, but black walnut, one of the things that it does, if you notice this, how dark that stuff is and how it's kind of got this oily appearance, and if you come over here and mess around in it, okay, it's kind of black, okay, almost like dirt. Okay, and something that black walnuts have is one of the chemicals that they produce is something called juglone. Now, juglone is what we call an allelopathic compound. Allelopathic compounds are something that certain types of plants will produce in order to limit competition. Okay, so one of the things you'll notice is generally when you see black walnut, you're not going to have a lot of other things that are going to grow around them. Okay, so I mean, you might have certain species that will. There's some things that get along fine with black walnut, but there's other species that will not get along with black walnut at all. Okay, and the thing is, this compound, what happens is it's found in the tissue of these trees, it's found in the nuts, it's found in the leaves. So I mean, if we look all through these trees, everything on here that could fall to the ground, okay, has juglone in it. Okay, the nuts, everything. And so what happens is this juglone, as those holes around the nuts rot, it penetrates the soil. It's picked up by soil microbes that then will disperse that through the soil. And when those particular soil microbes break that material down, it injects it into the soil, so that if something comes along here that cannot tolerate juglone, it won't survive, and thus reduces the competition that these trees would have if something were growing up around them. So if you notice, these trees are getting quite big here, and there's nothing, absolutely nothing, standing around them as far as other trees, and that's the way it'll be. Over here you see my father-in-law's garden, okay, and he has to make sure that what he plants in that garden is something that's going to tolerate juglone, because if he's not careful, if it's something that won't tolerate juglone, it won't grow well. So that's how toxic it can actually make the soil. Most people don't even realize that, but sometimes they might wonder, well, I don't know why my this particular plant I've put out here is not growing well. Well, if they planted it under a black walnut, then that could very well be the explanation. There are a couple little red cedars that are coming up over here. Red cedar is a species that can tolerate being around black walnut. Okay, but they're looking a little poor. So we'll just have to see how these little guys do. I may transplant these little buggers and see if we can get them to grow in a pot. We can do some bonsai work with them or something. So that might be an interesting little project. There's some poison ivy growing on this particular black walnut. I don't think poison ivy is sensitive to anything because it pretty much grows everywhere. But I wanted to show this to you guys because I thought you would find it interesting. It goes along very well with what we're doing right now in class. So hopefully you learn a little bit of something here, and we can look and see how we can apply this to other aspects of horticulture as we start moving on and think about pruning, and we think about rooting compounds and growth hormones and stimulants and retardants and those kinds of things. Then it gives us some idea of what we're dealing with, and understanding how anatomy and physiology has an effect on how a particular plant grows. So black walnut's a good example to show you guys.